Hello all. Today's lesson is on Student Expectation 8.5c, which states that the student will interpret the arrangement of including groups and periods to explain how properties are used to classify elements. Our focus today is going to be on how to locate and use your periodic table to locate the metals, nonmetals, and metalloids. So I have printed out a periodic table. If you have the ability to print, please get one and follow along with me. You can pause the video at any time you need to ensure that you are on track. All right, so we are going to, like I said, color code this periodic table according to metals, nonmetals, and metalloids. So I'm going to label it as such: metals, nonmetals, and metalloids. All right, so we are going to review this information. So the easiest way to use the periodic table is to first understand that most of the metals are going to be to the left of the stair step, and this is our stair step. Some people call it a zigzag line. I refer to it as a stair step. So most of the metals are on this side, nonmetals to this side. So for that purpose, we are going to extend our stair step or zigzag line so that I can indicate this here. So to one side of the zigzag, we will mainly have the metals, and to the other side of the zigzag line, we will have our nonmetals. So nonmetals are on this side in general, and the metals on this side. All right. So along the stair step itself, and I'm going to kind of extend it here and just right at the bottom, that along the stair step we have the metalloids. And this is the easiest way to locate if an element is a nonmetal, metal, or metalloids. Use your stair step as your reference. So we're going to start in the middle with the metalloids because they are kind of easy to identify because those are the ones that touch the stair step. So metalloids, first off, touch stair step. Characteristics of metalloids would include things like they have, because they're kind of located in the middle, they do have, these elements have characteristics of both metals and nonmetals. So they have characteristics of metals and nonmetals. And one more thing that makes them unique, these are what are known as our semiconductors, meaning that they only can conduct electricity or heat energy under certain circumstances. So that's why they are referred to as these semiconductors. All right, so where they're located, they touch the stair step. Characteristics is they have characteristics of both a metal and a nonmetal, which we will discover what those are in a minute. And those are known as our semiconductors. So, shading these in, I need to know that there is, unfortunately, as usual in chemistry, there's one exception to this rule. Aluminum, which also touches the stair step here, see the element touches the stair step, it is not a metalloid. This one is the exception. it is a metal. And since we all know aluminum is metal, kind of makes that easy to remember. So we're just going to kind of make a little star here that this is an exception. Is aluminum. It touches the stair step, but it is not a metalloid. And then we're just going to go down and shade in all the elements that actually, where their keys or boxes, element boxes, touch the stair step. We're just going to shade them all yellow for metalloid. All right. So those are our metalloids on the periodic table. Now let's look at where our metals are. We already know aluminum is a metal. We've identified it. We know that metals are supposed to be to the left of the stair step. Some of the characteristics of metals include they are conductors of heat and electricity. They are what's known as malleable, meaning you can bend them, you can flatten them out, and I have some examples here for you. I have copper here. This is a copper strip, and as you can see, it's been flattened out. This copper has been flattened out, and it's very bendable or malleable, easy to bend, right? Another one that you are all very familiar with is one you have in the kitchen, aluminum foil, right? This aluminum foil has been flattened out to where we use it in sheets. We can bend it, we can hammer it, we can flatten it out. Obviously, it's malleable. That's what that means, malleable. Can be flattened. But metals are also have another unique quality. They are ductile, meaning that they can be pulled into wire. So here is some copper wire. So this, in this instance, here was my flattened piece of copper, and here is my copper wire. So you can see that it is ductile, meaning it can be pulled into wires. All metals are malleable and ductile. Of aluminum wire. So if you ever were wondering, can you do that with aluminum? You sure can. So here's a piece of aluminum wire. So metals, all metals are malleable, can be bent, flattened, and are ductile, can be made into wires. All metals are shiny or have luster. And as you can see in these instances, my metals were nice and shiny. They all have luster. They reflect the light nicely. That's what that means, to have luster or be shiny. You reflect lots of light. So here's another piece. This is actually a piece of zinc that has been flattened. So all of these are now nice examples of malleability, ductility, and luster. All right. Most metals, except for one, are solid at room temperature. So most are solid at room temp. That pretty much concludes the characteristics of these. Now let's shade them in on the periodic table. Let's locate them all. Remember, we said all the metals are to the left of the stair. Okay. All right, so let's go ahead and shade them in. We already had shaded in aluminum. We do, as we shade in our metals, we do have another exception on the metal side of the periodic table. And we're going to go ahead and shade that one in really quickly. That would be hydrogen. Hydrogen is on the side of the periodic table that includes the metal, but it is an exception. It's another exception. It is a nonmetal, and we'll get to those in just a second. All others now are just shade them in whatever color you choose, so you know, oh, okay, these are my metals. And I'm not doing this, I'm doing this kind of fast so that you just get a good idea of where all of these are located. Remember, this stair step is the key. The stair step tells you this is where we separate metals from nonmetals. So if you can't color in, that's where you start, at the stair step. The ones touching are metalloids. The ones to the left are going to be our metals, remembering your two exceptions. Okay, so if you can't color code and do what I'm doing, those are the things that will help you remember the best where to locate certain elements. All right, now let's get to our nonmetals. Our nonmetals obviously are on the right of the stair step. So what are some characteristics of our nonmetals? Well, I've brought in a nonmetal here I'd like to show you. This is actually coal, and not the kind of coal, not charcoal, but what's known as bituminous coal. And so if you can look at it, it is not shiny. So it is in a plastic bag right now. Let me get it out so I can show you. It is not shiny. It's very messy, actually. I don't want to really. But it is not shiny. It's dull. It, as you can see, this was once one piece. It is now broken into several pieces because nonmetals are easily broken. We refer to them as brittle solids because they break very easily. That was carbon, actually, what I just showed you. Here is sulfur. Sulfur is another nonmetal here. If you see, it's just crumbling in the bag, the little pieces. It is not shiny, and let's look at it again. It is very dull. So it's not shiny at all. It's not shiny like my metals, right? There's no comparison here to this shiny. This is dull. So one of the characteristics is that nonmetals are dull. Most of them are gases at room temperature. And if they're solids, they are brittle solids. So they break easy, just like we just looked at, right? Just like these are just kind of flaking apart here with little bitty pieces all in the bag because they break so easily. So brittle solids. Also, they do not conduct. So these do not conduct heat or electrical energy. They are not conductors. Of heat or electrical energy. All right. So let's shade them in. Those are the main All of these are the main characteristics of our nonmetals. We're going to shade them in. Remember, we had to pick up hydrogen over here because it is a nonmetal as well. So remember your exceptions. And then we're just going to shade these in over here. All right, so now we have our characteristics listed for our metals, nonmetals, and metalloids. I do want to come back to the metalloids that are touching the stair step. So the metalloids that are touching the stair step, we said, had characteristics of metals and nonmetals, meaning that whereas the metals were shiny and the nonmetals were dull, some of these might be shiny, some of these might be dull. Whereas we had some metals that are good conductors and nonmetals that are not good conductors. Some of these might be good conductors under certain circumstances, and that's what we refer to as a semiconductor. I have silicone right here. So let me show you what silicone looks like and see if you can identify some of the characteristics of metals in this metalloid or nonmetals in this metalloid. So take a good look. Let me take some out of the bag so you can see it better. If I could get the bag open. And so here we go. Here's what it looks like. So if you said, well, it's shiny or it has luster, just like a metal, you are absolutely right. It has shiny and has luster just like a metal. But if you looked in my bag, or look now, you can see that it is a solid at room temperature, but also that it is very brittle or breakable. So it breaks very easily. So it is one of the characteristics it has from this side is it's a brittle solid, right? Silicone, I'm not sure. I didn't check to see if it conducts or not, but we know that these metalloids can have characteristics of metals and of nonmetals both. That's what makes them so interesting. That's what puts them in the middle of these two on the periodic table, is that they have characteristics of each of these. And they are those semiconductors that you need for your video games and your cell phones to function properly. All right, before we end this lesson, so some of your tasks might be to identify if an element, based on some characteristics of the element, if it's a metal or a nonmetal, or you might have to actually look at the periodic table and find it and tell me if it's a metal or not. So that will be some of your challenges to come on your practice. If I told you I have an element and it is a poor conductor of electricity, it's mainly a gas at room temperature, and what might you think it is? A metal, nonmetal, or metalloid? So if you said it would be in this group, you're absolutely right. That would be characteristics of a nonmetal. So we would be looking for elements in the blue shaded area, the nonmetal area, to match to that description. If I told you I am an element that has characteristics of both a metal and a nonmetal, I am dull, but I do conduct electrical energy, you would be looking for an element that falls into that metalloid category. And if I told you I was shiny, I'm a shiny solid, I bend very easily, and I can be pulled into wires, or I'm malleable and ductile, you would be looking at all of the metals to try and identify which element is being asked for. So I hope you enjoyed this lesson, and I hope that you are able to complete the activities that follow. And good luck on STAR, guys.